Hi everyone. So let's start with the entire revision for your physics paper 2. I know I'm quite late, but I was not having any time to actually make this file. So let's start now. Since your exam is going to start at 7 p.m. Bangladesh time, so I think for this time being, like whatever the time duration that is left before the exam starts, it would be enough to actually go through this entire video and revise all the question papers and all the concepts that will be related to your question papers. So watching this video will actually cover your question paper solving from 2022 to the latest paper. And again, obviously, as I'm going to explain everything in as much detail as possible, so obviously watching this video will brushing up your entire concepts about all the theories and all the mathematical terms that we're going to use or find in these files. And again, our May 2025 batches are going to start from this June 20th after Eid. And if you guys are interested for our maths and physics and IT classes also, so 1 minute, I'm sorry, I don't know why I cannot write on this. So if you guys are interested for maths, IT, and physics for your A levels, A's, and A2, we are providing your classes for from this 20th June. Trial class will start from 20th June for all these three subjects. If you are interested to join our trial classes, please inbox us in our WhatsApp or email us, or you can also use our Discord group to reach to us and then let us know what are the details or inquiries you have about our trial classes. And also, not only for this May 2025, for those of you who are going to sit for your October 2024 second session exam, our batches for crash courses for IGCSE, physics, maths B, pure maths, and biology and ICT, these are all open. So if you guys are interested for the crash courses for the October 2024 also, please inform us using the same WhatsApp or email address or our Discord group. And again, these trial classes, if you're going to join the trial classes, I mean, even if you want to join our classes or not, if you want to understand, have a basics about which units you should take with physics or IT for your A levels in maths, or what are the subject procedures that should be better for you according to your future or subject selection, please join our trial classes on June 20th or around June 20th for these three subjects, maths, physics, and IT. And we'll try to help you, reach out to you, and give you the solutions as much as we can. So let's start. Now then again, in this entire physics paper 2 file, these are all the questions taken from your paper 2. Paper 2 and paper 2R for the recent question papers. And I have sections this entire file into 7 sections. One for kinematics. Kinematics will have all the questions from your unit 1 basically, that is forces, momentum, work done, and all those concepts. And then again after this you have electricity, electromagnetism, waves, all those concepts are serially arranged in terms of chapter. So let's start with this one. A squash ball is made of rubber and used to play a game called squash, and the student observes that the squash ball bounces higher after its temperature increases. The student investigates and so the student designs an investigation to see how the temperature of the ball affects the maximum height after it bounces. Okay, now over here, the student was trying to investigate that how temperature was affecting the height of every bounce, right? That means temperature over here is the thing that I'm going to control over here. And depending on the temperature, the maximum height reached after the bounce will automatically get modified. Now we need to state the dependent and independent variable in the student's investigation. So the independent variable is temperature, and the dependent variable over here is your maximum height after the bounce. So I'll just write maximum height after bounce. Okay. Now this was for part A. Let's move on to the next question. The diagram shows the ball at its maximum height after it bounces. Determine the distance the ball moves from the floor to its maximum height. Assume the ball does not change the shape when it bounces. And it is also stated that on your diagram, 1 centimeter will represent 4 centimeter in lab. So over here, you have to take measurements from the diagram. I can understand that I have to take the measurement from this ball, bottom of this ball to this floor. I have to measure the length of this blue line, but I obviously cannot get an accurate value because this is exactly from a diagram, right? A diagram will not give me an accurate value. So I'll just use a mark scheme. That on a mark scheme, they're saying that on your real paper, you are supposed to get a distance of 6.2 centimeters on the paper. And that means again, I have to use unitary method to find out then how much that will be in lab. So this length is 6.2 centimeter. So I have to do the conversion over here. That distance on diagram or on paper, that is 6.2 centimeters, and then again distance in real life or in lab, that is going to be 6.2 multiplied with 4, which is going to be 24.8 centimeter. Okay, that is the final maximum height reached by this ball after the first bounce according to this diagram in the real life lab. And then again, it is stated that a student, sorry, design a method that the student could use to investigate how the temperature of the ball affects the maximum height after it bounces. Your answer should include details about the apparatus used, measurements required, and the control variables. And I can also draw a diagram to support my answer. Now over here, as I'm trying to draw a diagram, obviously I will use meter ruler to measure the height in order to make sure that the height is like this meter ruler is only going to measure the perpendicular height or vertical height. I have to make sure that the entire meter ruler is perpendicular to the ground, right? So I'll just draw the diagram over here because I do not have much space. So I'm considering this is the baseline, this is the floor, and this is your meter ruler. In order to make sure that the meter ruler is entirely perpendicular, I'm going to use a set square. Okay, this is how the set square will look like. And obviously I am going to throw that ball from a certain height. So I'll make sure that the height is fixed for every, I mean, obviously as I'm trying to carry out an experiment, I would obviously have to repeat for different temperatures over here, right? I would have to repeat the entire experiment at least 2 times for each temperature. So for that repetition, the control variable over here should be that the height from which the ball was projected before the first bounce. And that height should always remain constant. For every repetition, this height should remain constant. So in order to keep this height constant, I will start from a fixed height above a bench. Okay. So this is your bench. And this is your meter ruler that will actually measure the height reached after the first bounce. And this is your set square in order to ensure that this meter ruler is entirely perpendicular to the ground. Other than this, nothing are important. I mean, you can make this diagram more accurate by adding these lines over here. Again, you can add lines on the set square also, but I'm not going to add anything on the set square. I'm just going to add these lines on the meter ruler, and then I'll move on to the writing part for this answer. And then again, they're giving you 6 marks, and they have also provided you the overall working pattern that there are 3 sections that should be included in your answer, and those sections are the apparatus that you need to use and the measurements that you're going to be required to measure using the apparatus you have mentioned. And then again, you have to find out or state the control variables and exactly how the control variables will actually uh, change or have to be controlled over here, or how would they actually affect your final results. All these things has to be categorized into these 3 sections. So obviously we'll start with the fact that what apparatus we're going to need. We'll start with that we would need meter ruler and water bath with thermometer. And then we'll start with the measurements, like what are the measurements that we're going to do using the instruments we have mentioned above. So firstly, we'll see that using the thermometer and water bath, we will measure that we will use a temperature within a range of maybe from 5 centimeters to 30 centimeters with 5 degrees Celsius interval. Like every time, I'm going to take maybe I'll change the temperatures within the 5 degrees Celsius interval. Like first 5 degrees Celsius, then 10, then 15, 20, 25, 30. Similar to that, that represents 5 degrees Celsius interval. And then again, I will measure the height after every bounce using the meter ruler. right? And obviously, I'll try to make sure that the height that I'm measuring is at the eye level, is at my eye level, right? In that case, in order we would have to prevent, if I'm going to measure the height according to my eye level, that would automatically eliminate the parallax error from my calculation. So let's start with the writing then. Meter ruler, water bath, and thermometer should be used. Using the meter ruler and thermometer, we can change the temperature within a range of, let's just say 10 degrees Celsius to 45 degrees Celsius. With 5 degrees Celsius intervals. Okay, and then again after this with 5 degrees Celsius intervals, and measure the height at eye level of the ball after first bounce. And measure the height at eye level after every bounce, or after first bounce actually. And obviously repeat the experiment twice at each temperature to calculate mean. So we should try that also. Repeat the experiment twice at each temperature to calculate mean. And after this, we just have to talk about the control variables. For example, over here, the first control variable is the height from which you're going to drop the ball, the initial height from which you're going to drop the ball. That has to be constant. And again, the room temperature should also be constant, because that would also like modify your temperature of the ball, right? Surface of the ball. That is also a fact that should be controlled. So the control variable is, there are two control variables: room temperature and your initial height from where the ball is dropped. So it will be double P. From where the ball is dropped should be constant, should be controlled to make the experiment fair. To make the experiment fair. Now, this is it for the description part. I think focus on writing the description parts more, because they actually contain a lot of mark, right? And also for the diagrams, whenever you're going to mention, like whenever in a question they have mentioned this type of statement that you may draw a diagram to support your answer, always try to keep a diagram over here with reference to your answer. Okay, always try to add a diagram if you have time, obviously. Okay, so this is how the question looks like. By the way, this was from Jan 23, paper 2, question 4. So let's move on to the next one. This is again from Jan 23, paper 2, and this one is about moments. Now, this one says the diagram 1 shows a wooden plank balanced horizontally on two supports A and B, and a block is suspended from the plank between the supports by a cable of negligible weight. Okay, the cable does not have any weight itself, and then again they're saying that the weight of the block is 260 Newton. You have to link a formula for moment, force, and perpendicular distance from the pivot. I can clearly understand this is the product, and these two are to be multiplied together. So this is going to be moment equals to force with perpendicular distance from the pivot. Right? So always try to use all the words for a quantity that were used in a question. For example, I could have stopped writing after perpendicular distance, but in a question they were using perpendicular distance from the pivot. So try to take all the words in your question that they've used to provide for one quantity. That will be much more secure to write your answer in this format. And after this, it says that by taking moment from support A, like you're going to take the pivot from support A, you have to calculate that unknown force, and we have to again assume that the plank does not have any weight itself. Again, we can see over here is this cable obviously going to provide a clockwise force, and this F newtons is going to provide an anti-clockwise force, and you're taking moment about this point. Another thing, all the distance are in centimeter, which obviously has to be converted into meters. And then again, the weight over here, the weight of this block was 260 Newton, and it was 25 centimeters or 0.25 meters. But I can write this as 0.25 meters away from the point A. And then again, this force is actually 25 plus 55, which is 80. So this is going to be 0.8 meters away from support A. This is for anti-clockwise and this is for clockwise. So I can easily use the concepts about your moment in order to find out the unknown force, or law of conservation of moment, or law of moment, in order to find out that unknown force. For that law of moment, this is going to be sum of I'll start with anti-clockwise. Sum of anti-clockwise moment is equals to sum of clockwise moment. For sum of anti-clockwise moment, the force was F. We do not know the value for this, but it was 0.8 meters from point A. And sum of clockwise moment, this was 260 Newton, and it was 0.25 newtons away from that support at A. Finally, F is going to be 260, 0.25 over 0.8. And if you calculate this, you're going to get the value for this entire force as 81 Newton. Okay, so this is the value that you're going to get. So let's move on to the next part. We need to explain what will happen to the magnitude of the force if the block is moved towards support B. Okay, now let's see this exactly how that happens. For example, when this block B of 260 Newton is going to be moved towards support B, that means obviously that will increase the distance of this 260 Newton from the support from the pivot A. And according to our equation again, if we're going to increase the distance, that will totally increase the clockwise moment acting on this beam, acting on this plank. And in order to make this plank in balance situation, in equilibrium position, the anti-clockwise moment should also be increased, because now it has a higher clockwise moment acting on the beam, right? Because of the increase in distance from pivot A of this 260 Newton block of weight, because of the increase in distance between the block of weight and support A, this clockwise moment increases overall on the plank. In order to balance that increased clockwise moment, the anti-clockwise moment also has to be increased. But problem is that point F or force F is already at the maximum distance from support A. I cannot increase the distance for this time for this force, but I can increase the value for the force over here. So in order to keep the entire beam or plank over here in balanced in equilibrium position, the total anti-clockwise moment also have to increase. And according to your equation again, since I cannot any further increase the distance, as force F was at a maximum distance from the pivot A, so distance increasement is not possible for me, but I can easily increment the value for my force acting on this plank at point B as a force F, right? So in order to increase the total anti-clockwise moment, in order to balance out the beam or plank over here, the value for this force must increase in the upward direction, in the anti-clockwise direction. That is your final answer. Let's write this down over here. So this is going to give you 3 marks. So let's start with the fact that increasing distance of increasing distance of block, increasing distance between block and the support A. So, increasing distance of block and support A. Increasing distance of block and support A. Increasing distance of block and support A causes increase in clockwise moment. Causes an increase in clockwise moment. And then again, increasing distance of block and support A causes an increase in clockwise moment. Now I'll stop this and then I'll write again. In order to keep the beam balance, anti-clockwise moment must increase. Must increase, which indicates the value for the magnitude of force should increase. So 1 minute should also increase. Okay, so this is it. Now let's move on to the next part. For part B, it says the diagram 2 shows the block and the cable connected to the block, to the plank. And this is the cable and this is your center of gravity from where the entire weight of this block will appear. And we stated that the center of gravity of the block is located at point X. And we need to draw an arrow on the diagram to show the weight of the block. Calculate an arrow on the diagram. So draw an arrow on the diagram to show the weight of the block. Okay, that we can clearly understand from this center in the downward direction, right? That will give you the weight of this block. This is your weight. Maybe you're getting 2 marks over here for the arrow and for the size also something. And again, since you have cable over here, so obviously there will be a tension acting on this particular block, right? And tension should act from the surface, like in this direction. The tension should act in the perpendicularly upward direction. This is your tension. And after that, it says that the block also experiences a force due to tension on the cable. Explain why the block remains stationary when it is not supported by, so when it is supported by this tension force. It remains stationary because of Newton's first law, right? It remains stationary because this tension, like the magnitude of the tension and weight were equal, but they were acting in opposite direction. So for example, if the tension is 5 Newton and weight of the block is also 5 Newton, and if they're working in opposite directions and they're obviously vector quantities, so one will be assigned with a plus sign and one will be assigned with a minus sign. Eventually, you're going to get 5 minus 5 as 0 Newton. So whenever two equal sized forces acting in opposite directions act on the same object, they eventually cancel each other out and the resultant force becomes zero, which means the acceleration is also zero, right? So if the acceleration is zero, obviously there is no motion for the particle. The particle remains at rest. That is your answer over here. So let's write the answer that but they act in opposite direction. So obviously they cancel each other out, making resultant force equals to 0 Newton. Okay, that is your final answer now. Let's move on to the next one. Explain why the forces acting on the block are not an example of Newton's third law. Remember this first point that in order to be under Newton's third law or first law, they need to fulfill the 5 criteria. Let me just write down the laws over here. Okay, so these are the 5 points which actually distinguish that if a pair of force will be Newton's first law or third law. Now over here we were speaking about tension and weight, right? So tension and weight in the previous part also we understood that obviously they were of equal in magnitude, opposite in direction. That's why the total resultant force was zero. It kind of resembles with the Newton's first law, but then again, in order to be under Newton's first law also, the forces must be of same type. Over here, tension is the contact force, and your weight is a gravitational force, or it is a contact-less force, right? So these are two different types of force. These are not the same type of force. That means, as it does not satisfy the second point, for Newton's first and third law, actually, this is third law. So we can understand that obviously this will not be under any Newton's first law or not under Newton's third law, right? This one indicates that, okay, the forces are not of same type. That means obviously they are not of Newton's third law here. And then again over here, the last point is different for the Newton's first law and third law, by the way. This is third law. For to be any pair of forces to be under Newton's first law, the forces must act on the same body. And then again, in order to be under Newton's third law, the forces must act on two different bodies. Over here, both the tension and the weight, even though you forget about the fact that they're not of same type, you just consider for one time that they are of same type. Okay, even then also they will not be under Newton's third law because tension and weight, they are both acting on the block, right? They're not acting on two different bodies. They were acting on same body. So obviously, in any case, they will never be considered as Newton third law pair forces. And I should just correct this out. 1 minute. This is third law. And they're giving you 2 marks for this question. So I just did this to the bottom. 1 minute. I'll just keep it over here. I'll write the answer for that part in this section. The final answer should be that the forces act on same body and they're not of same type. And they are not of same type. Okay, because of these two reasons, we will not consider them as a pair for Newton's third law. I hope this entire chart and everything is clear for you to understand. We'll then move on to the next question. Okay, this question is from Jan 23 2PR, question 7. So let's start. This is again from Kinematics. So over here it says a crumple zone is a safety feature in a car. It is part of the car that is designed to collapse during a collision. A student investigates the effectiveness of crumple zones and the student rolls two model cars down a ramp. each car comes to rest when it hits a large metal block. This is the metal block, and each car comes to rest when it hits this large metal block, and the data logger measures the mean force applied to the car during the collision with the block. Okay, the data logger will measure the amount of like average force that will be applied onto the car by this metal block during the collision. And this is the diagram, shows the equipment used in the investigation. Car 1 has a paper crumple zone at the front, and car 2 has no paper crumple zone. The table shows the students' results. Car 1 and 2, mean force on car from block in newtons, and then velocity just before car hits the block over here. Velocity is same, right? The final velocity with which the car 1 and 2 will hit the metal block is same, but then again the mean force for like from the block on each car is different. Car 1 had a crumple zone, and that's why it was receiving a smaller force, and car 2 did not have any proper or paper crumple zone, and it was receiving a higher force. We need to say that the mass of each car is 0.074 kg. We need to calculate the time taken for the velocity of car 1 to decrease from 3 to 0. Okay, we can easily calculate that. 1 minute. Using the force and mass, I can calculate force. Yeah, using the force and mass, I can calculate acceleration, and using that acceleration, I can calculate the time taken. So this is how I'll have to arrange the equation. I'll start with obviously F equals to ma, where further I'll break down that ma into delta V divided by T, and F over here I already know the value for F, that is for car 1 I'm trying to find out, right? That means the car 1 was receiving 2.5 Newton, so force is 2.5, mass is 0.074 multiplied with delta V over T. This is 3 minus 0 divided by time. The time for us is unknown, and 3 minus 0 is just 3. So now over here, if I make the time the subject of this will be 2.5 divided by 0.074, and then again further this entire thing will be multiplied with I'll just wait 1 minute. I'll just write it like this, that 2.55, this 0.074 actually gets multiplied with the numerator, and obviously on the numerator you just have 3, right? 3 minus 0 is just going to leave you with 3 divided by T. So now if you make T the subject of this part, this will be 0.074 multiplied with 3 divided by 2.5. So you're approximately going to get the time as 0.089 seconds. 0.089 seconds. So this was it, the calculation for the time taken for the velocity of the car 1 to decrease from 3 to 0 meters per second. We'll move on. Then again we need to state the magnitude and direction of the force on the metal block when car 2 collides with the block. Obviously this is a concept of Newton's third law. If block is going to provide a force on car 2 of 4.5 Newton, according to Newton's third law, same amount of force will be applied onto the block in the opposite direction, right? So if I'm assuming that this is your car 2 during the collisions period, and your block was exerting a force to the left with a Newton of 4.5 Newton magnitude, as a response, according to Newton's third law, the car will also provide a exact 4.9 Newton force on the metal block in the right direction, right? So this is your final answer. So over here I think they're giving you 2 marks, one for the magnitude, one for the direction. So magnitude is going to be 4.9 and direction is right opposite to that of car. So we'll just write down this, that magnitude is 4.5 Newton and direction is towards right. This is your final answer. Okay, that was it. Then it says that explain why the mean force from the block on car 1 is smaller than the mean force on car 2. Now this question is referring you to about the Newton's second law, where it says that rate of change in momentum is directly proportional to your force. Okay, so this question is related to this this conversion we did in our classes, in our theoretical classes, that delta P is equals to force over here. Now in this situation, as both the cars, car 1 and car 2, have similar masses 0.074 kg, and they were starting their journey from 3 meters per second, and then they will obviously come to rest at 0 meters per second, right? So the masses and change in velocity is same. Eventually their change in momentum would also be same. So change in momentum for both the cars, car 1 and car 2, is equal. But in this case, the car with crumple zone, that is basically car 1, has a longer decelerating time. So for a longer decelerating time, you can clearly understand that force and decelerating time are inversely proportional. In this case, this is how the equation can be rearranged. Delta P multiplied with 1 over T, and in this situation your delta P is a constant over here. So if your delta P is constant, that means force and time are inversely proportional. So the car 1 with crumple zone will actually have a larger decelerating time. For a larger decelerating time, it will obviously have a smaller force, because force and deceleration, or force and time, are inversely proportional. So that's why on car 1 it was exerting a small amount of force of 2.5 Newton, and then again on car 2 the metal block was exerting a larger force of 4.9 Newton. That is your final answer over here. And obviously they're not giving you much marks for this question, they're only giving you 2 marks. All the explanation I did would be worth for maybe 4 to 5 marks. So I would suggest not waste your time and write unnecessary points for just 2 marks. In this part, you should just stick to the question. That over here, that you can just suggest that according to the equation, F is equals to delta P over time. Since change in momentum is same for both the cars, and car with crumple zone, the crumple zone for car 1 increases the time, decelerating time, therefore force exerted on car 1 was smaller than in car 2. That is the only thing you should write over here. You do not need to mention much details about the change in velocities and how for everything detail I mentioned during the explanation. Those are not needed because they're giving you only 2 marks for this. So let's start with the working. Now it says that we're going to write with 2 minutes, 2 marks. Okay, let's start with that. According to delta P over time equals to force the change in momentum for both the cars, according to delta P over time is equals to force, the change in momentum is equal for both the cars. Increases the decelerating time. Car 1 will increase the decelerating time, therefore a smaller force will be exerted, right? Okay, now this is it for your question part C. Let's move on to the next question. Okay, next question is from June 23 2P, and this is again about moments. This question is about moments. Diagram 1 shows the raised lower leg of a person, and the moment of the weight of the lower leg about the pivot is 19 Newton meter. And wait 1 minute, the weight of the lower leg of the pivot is 19 Newton meter. Okay, like this one is actually 19 Newton meter. Okay, the moment of the weight. Okay, and the vertical force F is applied to the person's foot to keep the lower leg raised, and this is your F force. And then again it is stated that the lower leg does not move. That means obviously this statement over here, that the lower leg does not move, this one indicates that the object is in equilibrium, right? And in equilibrium, obviously it will follow the conservative law of moment, that is clockwise moment should be equals to the anti-clockwise moment, right? Object is in equilibrium. And now you have to calculate the magnitude of S using the formula moment, force and perpendicular distance from pivot. Now how can I find out that what would be the value for moment over here? Since I already know that the object was in equilibrium and clockwise moment should be equal to anti-clockwise moment, I'm considering this as my pivot, right? So this weight of lower leg was actually creating my clockwise moment. Okay, this weight of lower leg multiplied with 0.25 was actually giving you the value for 19 Newton meter. And again, I can understand only this weight was creating the clockwise moment and this force was creating the anti-clockwise moment. And as the object over here is imbalanced, is in equilibrium, that means if the clockwise moment is 19 Newton meter, anti-clockwise should also be 19 Newton meter. So I already know the value for this F, that is 19 Newton meter. So I'll just move on and start writing that this is 19, force is unknown, and perpendicular distance from the pivot is what? This is 0.55 meter, right? From the pivot to the very end, from where the force was acting, that was 0.55 meter. So that will be multiplied with 0.55 and eventually you will get F 19 over 0.55, and that is equals to 34.5. Okay, so this is equals to 34.5 Newton. And this is it. Let's move on to the next question. It says that which distance is used to calculate the moment of the weight of the lower leg about the pivot? Obviously the 0.25 Newton, right? Because this will be used for the moment about that force, and this will be used for the moment from this for that lower leg weight, right? This 0.28 is a useless part that is not needed. Only 0.25 and 0.55 were required, and we have used both of them. And then again it says that in part B, the diagram shows the person resting their lower leg on two supports this time, and there are forces from support A as force X and there are forces from support B as force Y, and then obviously the weight of the lower leg is acting in the downward direction like it was previously. It is stated that the center of gravity of the lower leg is 0.25 meter away from support A and 0.35 meter away from support B, which means the total length between A and B is 0.55, right? And explain whether force A or force Y is larger. Ignore the weight of the upper leg. Ignore the weight of the upper leg. Okay. We need to explain over here. We do not need to calculate. Okay, now for the explanation part, if you go back to this diagram, let's just assume that I'm going to take whatever point as my pivot over here. Okay, I'm going to consider like not exactly pivot, this is your center of gravity, right, from where the weight of the lower leg is acting. And in this particular position, when the leg is again at rest because of the two supports, that means overall clockwise moment is still equals to anti-clockwise moment, right? So if I'm going to assume this, that if the total anti-clockwise moment in the down, like if the total clockwise moment is again maybe 19, the total clockwise moment should also be 19. And over here, since I can understand that there are two forces acting on this particular leg, section of the leg, and their summations should be 19 Newton meter. And then I also have their distances available, that from support A to this center of gravity, the distance was 0.25, and then again from the center of gravity to support B, the distance was 0.35. Okay, now one thing I can understand is if the object is in equilibrium, that means the moment for force Y and the moment for force X should be again equal. Like, doesn't matter what their moment are, they should be equal over here. And one thing I can understand, that if X multiplied with the distance 1 is equals to Fy multiplied with distance 2, where distance 1 is 0.25 and distance 2 is 0.35. So from this part I can understand that if they have to be equal, since for this particular Y force it has a larger distance, right? D2 was 0.235 whereas D1 was 0.25. Over here, since it has a larger force, that means it must have a smaller force, and in order to balance out for the smaller distance, it must have a larger force this time. This one on the right hand side of your equation for force Y, it has a larger distance, and obviously that must be balanced out with a smaller force. And over here, since your D1 distance is smaller from your center of gravity, in order to balance out, your force X must be larger. So under this basics, we're supposed to read the answer or finally write our answer. So we should start with that force x should be shorter. So force x has a shorter distance from center of gravity, and in order to keep this object in equilibrium, the moments of the two forces must be equal, right? That means forces with smaller distance will have a larger magnitude and forces with larger distance will have smaller magnitude. In that sense, force x is greater than force y. I hope in that basis or in that explanation it was clear for all of you. We'll move on to the explanation part. This is for 3 marks, and we obviously have discussed only 3 marks in the explanation that I was giving earlier. So let's start with this, that to keep it in equilibrium, moment of two forces must be equal. To keep it in equilibrium, moment of two forces must be equal. And then we'll write that since force x has a shorter distance from center of gravity, center of gravity, so its magnitude should be larger, must be larger. Must be larger. Okay, now this is it for your question B1. I think it was clear for all of you. We'll move on to the next part. And it says that a bag of ice is placed on the lower leg vertically above the center of gravity. This causes the force x and y to increase. The bag is then moved towards the person's foot. That means obviously it was moving towards point y. And describe how force x and y will change as the bag is moved towards the person's foot. If you go back to the diagram again once more, I'll just remove all these things. Now, in addition to your weight of the lower leg, there's also a bag of ice over here. And after some time, this bag of ice has been positioned to this part, right? Very close to your force y or very close to your point y or support B. And we can clearly understand what happens over here, that obviously this one will cause a very will cause a clockwise moment acting on this foot, right? Because of the weight of this ice, it will create a clockwise moment. This one creates a clockwise moment. And obviously because of this weight of bag of ice, the total clockwise moment increases. And then again, if you consider about this, since I'll consider taking the moment from the center of gravity, from where the weight of the lower leg is acting. For this case, now as I have moved the much bigger weight on support B, so obviously on support B now we have a downward force, but on support A we do not have any downward forces, right? There could be a chance that this leg will now almost tilt on the center of gravity, right? Will not be connected to support A anymore. That is not the case, but this could be one of the cases. And even before that, when you're going to add any force onto this feet part or support B, it indicates now you have a greater clockwise moment. In order to balance the greater clockwise moment, it should be balanced with a very large anti-clockwise moment from force y, right? And then again, the total anti-clockwise moment should be same, because object has to be in equilibrium. The clockwise moment and the anti-clockwise moment has to be same. So if introducing this bag of ice onto this foot increases the total clockwise moment, in order to balance this, the total anti-clockwise moment for force y will increase. That means for force x they must decrease, right? So in this case, force X decreases, force Y increases, and the change in amount, for example, if previously force X and Y, for X and Y, for example, I'm considering that previously force X was having maybe 20 Newton and Y was having 20 Newton. By introducing this ice of back into this scenario, your force X might decrease by 5 and your force Y will increase by 5. So the change in amount in the decrease of X and in the increase of Y will be same, so that eventually the total forces acting in the upward direction remain constant. So which means if the final answer for this case would be that if X decreases and if Y increases, and by the same amount, in order to ensure the total force remains same. So we'll write if X increases by the same amount, therefore total force remains constant. So now therefore increases by the same amount to ensure total force remains constant. Okay, so this is it for your question. I hope it was clear for all of you. Quite tricky, I would say, because the theoretical parts are very tough. We'll move on to the next question. State the principle of law of conservation of momentum. We already know that it is they're giving you 1 mark for it. So for that 1 mark only, you can write that change in momentum is equals to, so change in momentum before collision is equals to change in momentum after collision. But if they were using this same question for 2 marks, then I would have to refer that provided that no external forces are acting on the objects during the collision. Okay, but that was only required for the 2 marks question. Since they're asking you for 1 mark, that means writing only that total momentum before is equals to total momentum after collision. That is enough. So I'll just write this in terms of symbols. Total momentum before collision is equals to total momentum after collision. Obviously you cannot write this in symbols, you have to write this in words. And we'll move on. Over here it says that the diagram shows an air track that can be used to investigate the motion without friction, and air comes out through a series of small holes on the air track, and the air lifts the glider slightly above the track. A small spacecraft engine floats at rest on a cushion of air, and this is your spacecraft engine on a glider, and these are your air holes, and this is your pipe through which you will enter the air inside this air track. State the momentum of the spacecraft engine when it is at rest. So when it is at rest, that means your velocity is 0. So it doesn't matter whatever the mass of your spacecraft is. If you're going to find out momentum, that is mass times velocity, and we are not aware what the mass of this spacecraft engine is. So I'll write m multiplied with 0. Anything multiplied with 0 always gives you 0. So at rest, the momentum of the spacecraft engine was 0 kg meters per second. And then after this part, in part 2, they are saying that the spacecraft ejects large number of xenon ions to the left. Xenon ions to the left. I think that this is where they're talking about. This is their left. And it is stated that the mass of xenon, a mass of this much kg xenon ions leaves the engine at a mean speed of this much kilometer. And now calculate the momentum of all the ejected xenon ions. That is basically mass times velocity, but problem over here is velocity is in terms of kilometers. We obviously have to turn into meters, right? So it will be right, we'll have to convert that into meters. So basically I'll have to multiply this with 1000, which is now 2.6 multiplied with 10 to the power of -8. But they're giving you 3 marks for it, right? That means you have to obviously first write down the equation, do the conversion, and then apply it in your equation. So I'll just write this in over here. P is equals to mv, where momentum is equals to mass is 2.6 multiplied with 10 to the power of -8 and multiplied with 26 multiplied with 1000. So if you calculate all of these things together, your final answer should be approximately 6.8 into 10 to the power of -4. 6.8 into 10 power minus 4, obviously in kg meters per second, because I did converted the kilometers into meters in this section, right? So your final unit is kg meters per second, not kilometers per second. In part 3, it says that state the magnitude and direction of the spacecraft's engine momentum after these xenon ions leave the engine. Obviously, as it was stated that the entire spacecraft engine was ejecting these large number of xenon ions to the left. That means its momentum also was working to the left for the xenon ions, and in response to that, there will be an equal and opposite force will be applied to the spacecraft engine. That means the equal amount of momentum will be exerted on the spacecraft engine in the opposite direction. So the magnitude of the momentum for the spacecraft engine is this 6.8 into 10 to the power of minus 4, and the opposite will be opposite, and the direction will be opposite to that of left, which becomes right. So I'll just write 6.8 10 to the power of negative 4, and this is towards right, and this is your final answer. After this, again it states that the ions exerted a force of 2.6 millinewtons. That means it has to be multiplied with 10 to the power of minus 3. So 2.6 10 to the power of minus 3 newtons out of the spacecraft engine, and the spacecraft engine has a mass of 1.2, and we need to calculate the acceleration and give an answer in two significant figures. 1 minute. Force is given, mass is given. I can easily calculate the value for acceleration over here, but I'm not understanding why are they giving you 4 marks for this. I think that is for the equation over here. Other than that, they're not using any other thing over here. You just have to use F equals to ma, and then make a the subject of this equation, which is basically force divided by mass. So you're going to get 2.6 into 10 to the power of negative 3, and this will be divided with that 1.2. So you're supposed to get 2.6 multiplied with 10 to the power of minus 3 divided by 1.2, and you're going to get 2.17 into 10 to the power of minus 3 meters per second. As we're supposed to keep our answer to two significant figure, then it should be better if we keep our answer as 2.2 into 10 to the power of minus 3 meters per second. Okay, that is the value of your acceleration now. I hope this is all the work for part 4. Let's move on to the next part. This is for part C. It says that the engine is designed to accelerate a spacecraft while the spacecraft is traveling through space, and the spacecraft carries a mass of 0.75 kg of xenon ions from the engine, and when the engine is used, this much kg of xenon ions leave the engine each second. A student suggests that this small spacecraft engine would not be useful because the acceleration it produces is very small, and we need to evaluate the student's result over here. So in order to evaluate the student's result, we have to calculate the acceleration also. Maybe 1 minute. Okay, now over here they have given you about ideas that the entire spacecraft engine starts its journey with 0.75 kg of xenon, and each second it's going to eject this amount of xenon out of the engine to provide that upward thrust, right, or forward thrust. Now in this case, I can understand this is a very small amount of mass that will be ejected from the spacecraft to provide the forward thrust. So which indicates that obviously to eject this very small amount of xenon ions, very small amount of fuel is consumed per second, and we can also calculate that exactly how much time it will actually require for this spacecraft engine to eject all this mass of xenon ions. We can use unitary method, that is 9.9 into 10 to the power of minus 8 kg. If this much of xenon ions is ejected in 1 second, then 0.75 kg would be ejected in 1 divided by 0.9 into 10 to the power of minus 8 multiplied with 0.75, and that will be equals to 757, like it's a very big number, but whatever you get, that should be again divided with 3600 to convert this into hours, and then again divided by 24 hours to convert that into days. Okay, So this will convert the total amount into days, and you're going to get approximately 87.68 days. So 87.68 days. That means it will actually take the entire spacecraft to eject this 0.75 kg of xenons for this 87, almost 88 days. And obviously we can understand that if that spacecraft is going to burn that fuel for a longer time, obviously a lower acceleration will be achieved, and that lower acceleration is also achieved for a longer time. So the low acceleration for a longer time will provide you with high speed change. Okay, and that will not be efficient for this entire case. And another thing to think about, that in the space over here, the mass of the spacecraft will also be there. Only not the mass of the xenon is there, also there is a mass of the spacecraft itself, right? So eventually the total mass of this entire system, it will increase, and if mass increases, the acceleration will be even smaller. So obviously this spacecraft engine is not a suitable or useful for this particular case, as it will obviously produce a very smaller acceleration. So let's just write the answer, and they're giving you 2 marks. So if you're just going to like write any of the 2 points I've stated, that will be enough for you to gain the 2 marks out of this. So I have did the calculation and calculated the time taken to actually eject out that entire 0.75 kg of xenon ions out of the spacecraft engine, that is 87, almost 88 days. So I'll just write this down as time taken to eject is this much days, and it is quite long. It is quite a long time to burn the fuel. Burn the fuel, and then again we'll write that the mass of the spacecraft will also be added, increasing the total mass, so the acceleration will be even smaller. Increasing the total mass. Even smaller. Okay, this is all the workings and explanations you should write to this for this particular question. I hope this question was clear enough for you, all of you, to understand. We'll move on to the next question then. This is from June 23 2PR, and it says that a pencil has a weight of 0.16 Newton. What is the mass of the pencil over here? Obviously we're using the equation W equals to mg, where g is 10, and you have to make mass the subject of this equation, which becomes 0.16 divided by 10, and this is going to be 0.016, right? Then again, this is in kgs, right? If I convert this into gram, that will be multiplying this with 1000 again. So if I have to multiply this with 1000, and wait 1 minute, let me just calculate this. 0.016 with 1000, this gives you 16, which is option B as your correct answer. We'll then move forward. This question is, I think, about moments, and the diagram shows the pencil with one end resting on a small block, and a finger provides an upward F force to the pencil to keep the pencil horizontal. The weight of the pencil is 0.16 Newton, and we need to calculate the moment of the weight of the pencil about the pivot, and we need to use the following formula. Obviously I have the following distance also, but this has to be converted into meters, because moment is always like the perpendicular distance for the calculation of momentum should be in meters. So 3.7 divided by 100 actually gives you 0.037. So this is the value for your distance in terms of meter, and I can easily calculate the moment about the pivot. So this is going to be 0.16 multiplied with 0.037, which is going to be 5.92 into 10 to the power of minus 3. Okay, now after this again we need to state the moment of the force F. Since I already know this was in horizontal, means this object was in equilibrium, right? And for to be in equilibrium, we understand the total clockwise must be equal to the total anti-clockwise. The total clockwise was this. So the total anti-clockwise was this, 5.92 10 to the power of minus 3. That means for that force Newton also, it would be 5.92 into 10 to the power of minus 3. Clockwise and anti-clockwise moment should be equal for an object that is in equilibrium. So for this part, I'm just going to write this 5.92 10 to the power of minus 3. And now you have to calculate or show that the value for that force was 0.08 newtons. I already know the moment, and the distance was also given from the pivot to that force F, that is 0.074. So I can use that and the value for your moment or of the force F to calculate the magnitude of the force F. So which is going to be F 0.074 is equals to 5.92 10 to the power of negative 3, and then again make F the subject, which is 5.92 10 power negative 3 over 0.074, and this one gives you 0.074. This is 0.08, which is exactly the value that your question was referring about, 0.80 Newton. That is the force. And this is it. We'll move on to the next question then. I think this is again from June 23 to PR. This is your question 4, and this is about momentum. The diagram shows two birds just before bird X catches the smaller bird Y, and both birds are traveling horizontally at constant velocities. So mass of bird X was 0.41 and velocity of bird X was also given 13 meters per second, and bird Y was not given. The mass and the velocities for bird Y was not given, and we need to state the momentum of bird X. Like show that it is almost about 5 kg meters per second. So this is going to be momentum, mass times velocity, 13 multiplied with 0.41. So 13 0.41, which is 5.33. Okay, now after this again it says that the momentum of bird Y just before it is caught is 0.15, and calculate the total momentum of the birds just before X catches Y. That means they're actually asking you about the momentum before collision, right? This is actually how the entire scenario is for this particular question. Before collision, they were moving in the same direction separately, and after collision, they got combined together, and then they were combinedly moving in the same direction with a combined velocity. Right? That is how the entire scenario for this question was, and they're specifically asking you that what was the total momentum before collision in part B. That's what they're asking you about. Total momentum of the birds just before bird X catches bird Y. That means before collision, right? We have calculated the total momentum for bird X in before collision was 5.33, and they have also provided you with the total momentum before collision for bird Y as 0.15. That means total momentum would be the summation of these two momentums for bird X and Y for the before collision scenario. So total momentum before collision is 5.33 plus 0.15, which is going to be 5.48 kg meters per second. Okay, that is your final answer. Then we'll move on. We need to state the total momentum of the birds just after bird X catches the bird Y. Obviously, momentum is always conserved, right? That means whatever the object's total momentum was before collision, that should also be same for the after collision part. So if the total momentum before the collision was 0.548, so 5.48, that means total momentum after collision would also be 5.48. So over here, total momentum after collision would still be your 5.48 kg meters per second. And then it has stated that the mass of like bird Y has a mass of 0.17 kg, and we need to calculate the value of the birds just after bird X has caught bird Y. Since I already know that over here after collision both the particles were moving with combined velocity, right, as they were connected. So this is how the equation would look like for after collision. Total momentum after collision was 5.48, and that is basically the mass of particle 1 or bird 1 was actually given somewhere. It was 0.41 kg, bird X was 0.41 kg, plus mass of bird Y was 0.17, and they now have a combined velocity v 5.48, which is now going to be 5.48 divided by 0.41 plus 0.17, and this will be equals to the final velocity over here is approximately going to be, 1 minute, let me just calculate, 0.41, 0.17, 9.45, 448 actually, but I can just write 9.45 as my final answer, or just 9.4 meters per second is also acceptable. So this is it for your question. Let's move on to the next question. This is from November 23 2p. This photograph shows a dummy during a test of the safety car features of a car in collision, and it says that before the collision the dummy in the car is traveling at a velocity of 14, and the dummy has a momentum of 1100 kg meters per second. So the formula linking momentum, mass and velocity, which is just going to be what? Momentum is equals to mass times velocity. Right, that is your final answer. Then we'll move on, that it says that show that the mass of the dummy is approximately 80 kg, and they have given you all the informations, right? Velocity is given, the momentum is given, so I just have to make the mass subject of this equation. So it will be mass 1100 over 14. That does give you 78.57, which is basically 79 kg, or I should just write this as 78.6 kg, right, which is approximately 80 kg, right? If I write my answer to 1 SF, then it will obviously match with your approximated value given in the question. So this is an accepted right correct answer. We'll move on to the next part. The dummy is brought to rest during the collision by a mean force of 15 kilonewton. Now you need to calculate the time taken for the dummy to be brought to rest in the collision. Now over here I can understand that obviously what is happening. Basically at rest means the change in momentum after collision should be 0, because at rest means the final velocity is 0, right? This is how I'll actually arrange the equation. The first equation for impulse is mv minus mu, which is equation 1, and the equation second is impulse equals to ft, that is equation 2. I'll just substitute the two equations, and this is how it will look: ft mv minus mu. Since it was clearly stating everywhere that the dummy was brought to rest, that means what? Final velocity is 0. This entire part is 0. So you're going to write force was also given 15 into 10 power 3 multiplied with time. Mass was also given 78.6 multiplied with initial velocity was given as 14, and over here t is basically 78.6 multiplied with 14 divided by 15,000. Now if you just calculate all these things, 78.6 multiplied with 14 divided by 15,000, you're going to get 0.0733 seconds. That is a very small time, and that is the time taken for your object to come to rest over here. Wait 1 minute. Okay, so you're going to get 0.07336 seconds. I will just write 0.073 seconds. That is the value for your time. Now, in the next part, it says that the car being tested is fitted with airbags. Use ideas about momentum and explain how an airbag reduces the force experienced by the dummy in the collision. Okay, now in this part over here, for this momentum and we need to explain that exactly how airbags will actually reduce the force exerted by the dummy. I mean, again, for this kind of situation also, we're going to relate to that particular situation, that change in momentum over time is equal to your value for force. Now over here, as I know that airbags will again do what, it will again work as the crumple zone, right? It will increase the decelerating time. If it increases the decelerating time, the change in momentum is over here, wait, let me just rearrange this. Change in momentum, force multiplied with time, right? Over here, the airbag increases the decelerating time, which eventually would decrease the change in momentum. And if there is a smaller change in momentum, obviously this eventually will reduce the forces experienced by the dummy in during the collision, right? All of these statements will actually relate to this following equation. So we can finally write that the airbags increases the decelerating time airbags increases the decelerating time, sorry, causing the rate of change in momentum to decrease. Therefore, force will also decrease. Force exerted by the dummy during the collision will also decrease, right? This is your final answer. I hope this question was also clear for all of you to understand. Now let's move on to this question. This is from June 22 2p, and this one states that this question is about momentum. Which of the following is the correct unit for momentum? That is obviously kg meters per second. This is not correct. Again not correct. Again not correct. That is actually for force, right? So this is your final correct answer. Kg meters per second, mass times velocity. And over here, even reading the question, I can understand this part will be what it is. State what is meant by the principle of conservation of momentum. I know this is what change in momentum before collision should be equals to change in momentum after collision, right? And then again, the diagram shows an object before and after explosion. The object breaks into two parts, P and Q. The parts move away from each other in opposite directions, and okay, previously the objects were combined together and they were stationary, and they have a combined mass of 4.8 kg, and after collision they move away from each other. Their separate masses are also given, and this value for the final velocity of particle q was not given. So we need to calculate the magnitude of the velocity of particle p after the explosion. I can understand that since they have involved multiple direction over here, I have to consider one direction as positive and one as negative. I'll consider this as positive and this is negative. So which means total momentum after collision is equals to total momentum before collision, which is now going to be 2.9 multiplied with v minus this 1.9 multiplied with 3.7. This is equals to again 0, because the before collision the two particles were at stationary, so velocity over here was 0. So finally I can write that for the value for v, it's going to be 1.9 3.7 divided by 2.9. That is 2.42. So the final velocity after collision for particle q was 2.42 meters per second. So this is it. Let's move on to the next part. It says that a child drops an egg from a height of 10 centimeters and the egg lands on the floor. Explain why the egg is less likely to break if the floor is converted into a thick carpet than if the floor were converted into a hard tile. Now this question again works like the concepts of your crumple zone and airbags. Okay, now over here, obviously this is only related to your concepts about that change in momentum would have to decrease, or specifically rate of change in momentum would have to decrease for a smaller force to be exerted onto these particles. That means this carpet over here is going to increase the decelerating time, and eventually this will decrease the rate of change in momentum and also causing a reduction in the force exerted, right? That is your final answer over here, and these are the 3 mark skim points for which you will get the 3 marks for this part. So this is going to be that first part is the carpet. Increases the decelerating time, which reduces the carpet increases the decelerating time, which reduces the rate of change in momentum, causing a reduction in force. Okay, that is your final answer. I think we have seen similar type of answer for questions related about airbags, crumple zone, and about this falling collisions part, right? So I would say that I can now consider this as a part of your repeated questions. So obviously try to memorize this type of answers very much clearly, as there's a very high possibility that this might come in your exams tomorrow. So we'll move on to the next question. This one is about diagram 1 shows a gate fitted with a spring mechanism. The spring mechanism shuts the gate automatically, and this is your spring mechanism, this is your gate, and diagram 1. And it says that the graph shows some data for an investigation into how the extension of the spring changes with an increasing force. We need to describe the relationship shown over here. I can understand this is a direct relationship, directly proportional relationship, for which an increase in extension or an increase in force will cause an increase in extension, right? That is a basic definition from the graph. So this is going to be that the graph shows a direct proportional relationship for which increase in force increases extension. Increases extension. Okay, now again after this, it says that in part B, describe how the gate viewed from above angle, and it is now quite familiar to you concepts about moments, right? They're considering this is as your pivot, and from your pivot there's a force of 40 Newton with a distance of 0.8 meters, 84 meters, and then again in order to keep it in equilibrium, there's also a downward force acting on this gate of F newtons from this pivot at 32 centimeters or 3.2 meters away, and the force the spring exerts on the gate is 480. We need to show that the moment of the force the spring exerts on the gate is about 400 Newton. That is basically 480 multiplied with the distance. So moment 480 multiplied with 0.84, that is 480 with 0.84, and that is going to be 403.2 Newton meter, and that is approximately to the given value, right? So this is correct. And then again it says that the minimum force needed to start opening the gate, we need to calculate that. Okay, in order to provide a minimum force, that means the object should be in equilibrium, right? That is the minimum force, and your force should be greater than that in order for the total clockwise moment to be greater than the anti-clockwise moment, then only the gate will start to open. So the minimum force is when the entire gate is in equilibrium, where this clockwise moment should be equals to anti-clockwise moment. So now minimum means even now the objects are in equilibrium. So then again, in order to find out that force also, the momentum is still 403.2. So this is going to be 403.2 multiplied with 320 over 100, which is 3.2, multiplied with 3.2. So not exactly this, sorry, this is equals to force multiplied with 3.2, and F would be 403.2 divided by 3.2, 403.2 by 3.2, which is 126 newtons. So the minimum force that should be applied onto the gate was 126 newton. And then again, after this, the spring is removed from for testing, and explain what will happen to the spring if the force applied to the extent the spring is too large. Wait 1 minute. Explain what will happen to the spring if the force applied to extend the spring is too large. Now over here it would extend beyond its elastic limit and it will not go back to its original length, right? That is the situation that can happen over here. So we'll just write that the spring will extend beyond its elastic limit, causing permanent deformation. Right, so this is it for your part D. So yeah, this is again it for all the cases for kinematics. This is all the question that we will solve for kinematics. Okay, these are all the questions for kinematics. I hope this was clear for all of you, and we'll move on to electricity in the next part. Okay, let's start with electricity. Now this question is from Jan 23 paper 2 question 1, and it is about the photograph shows a person using a roll of plastic wrapping to cover a plate of food. The plastic wrapping sticks to the plate due to electrostatic charges, and the passage explains why the wrapping sticks to the plate. Use words from the box to complete the passage, and each word may be used once, more than once, or not at all. Okay, now let's start. The person pulls a layer of elastic wrapping from the roll, and the forces between the layers of wrapping transfer particles called electrons, obviously, from one particle from one layer to the another, right? So this one is already used once. Let's move on to the next line. The layer gaining these particles acquires a negative charge. Obviously a layer which is gaining electrons will obviously eventually will have a surplus of negatively charged particles. So this is negative. So this is again used once, and the layer losing these particles obviously acquires a positive charge. Positive, and this has also been used once. And for the final statement, it says that the negatively charged layers of wrapping repels dash in the electrons. As they're repelling, obviously they're talking about electrons, right? Because negative charges will only repel the negatively charged electrons. So this is again electrons, so we are actually using electrons twice over here. And then finally the wrapping and plate dash due to them having opposite charges. Opposite charges always attract, so this position we are going to use attract, right? So this is your final case for question 1. I hope this was clear for all of you. We'll move on to the next question. Now this is again about nuclear power reactors. Okay, it says that Korea nuclear power plant in South Korea is one of the largest nuclear fission power stations, and the reactors at Korea use nuclear fission to generate electricity, and the products released during nuclear fission have high energy in their kinetic store and give a product of nuclear fission. In nuclear fission, what 3 daughter neutrons are produced, slow moving neutrons, and then daughter nuclei, barium and krypton, are produced, right? So these are your products for nuclear fission. So you can just write slow moving neutrons. as a product of your nuclear fission. Right, slow moving neutrons. And then again, for part B, it says give two disadvantages of using nuclear power stations to generate electricity. Obviously, the first one is that they produce radioactive waste materials, and the second one would be that they're quite expensive. But no, let's think of anything else. Let's just write the first one, that they produce radioactive waste materials. And for the second part, we can write about they are non-renewable source of energy, right? They will eventually run out, so that is also a disadvantage. Source of energy. Finally, it says that what is meant by the term power. Power is basically work done per unit time. So we can write it is work done per unit time. Let's move on to the next part. They want you to calculate the minimum time taken for Cori to transfer this much amount of energy. Obviously, they've given you power. You just have to basically divide energy with power to get time. So this is going to be power is equals to work done with time. So finally, if you want to make the value if you want to calculate the value for your time, then you have to basically divide energy with power. Sorry, 7.49 10 to the power of 9 divided by 6.47 10 to the power of 14. So which is going to be 1.16 into 10 to the power of minus 5. Okay, that is the time taken for the Cori power plant to transfer this much amount of energy using that power. And this is it for the working. Let's move on to the next question. Okay, this is also the end for this question, by the way. Let's move on to the next question. A tumble dryer is a household device that dries clothes, and the clothes rotate in a heated cylinder. The clothes often stick together when they are dry because they become electrostatically charged, and the student investigates how different materials charge electrostatically in a model tumble dryer. The diagram shows the model tumble dryer. This is the cylinder and this is the direction of rotation clockwise, and the squares over here are squares of material. Okay, this is the student's method. Put 4 dry squares of the same material into the cylinder. Rotate the cylinder at constant speed for 3 minutes. Remove any square that are stuck together. Measure the forces needed to pull the squares apart, and then again repeat this for squares of different material. Okay, name a device that the student could use to measure the force. They can use Newton meter, right, to measure the force in order to pull the squares apart. So Newton meter. And state the dependent and independent variable in this investigation. The independent variable over here is actually going to be the material with which the squares are being made, and the dependent variable is going to be the force, right? Because depending on the material, the forces will be different. And dependent variable is force. State one, we have to state a control variable in this investigation. I can think about the speed of the rotation over here. For every different material I'm going to use, I will use the same speed for the rotation of the cylinder. So speed of the rotation for the cylinder, that could be a possible controlled variable. Okay, and part B says explain how the squares of material stick together. You need to use ideas about electrostatic charges in your answer. Obviously, what happens is firstly because of friction, right? Because of friction between the pieces of material, electrons transfer between the squares, and one become positively charged and the other become negatively charged, and square, yeah, the one that become negatively charged, obviously it gains electrons, and since the squares will become oppositely charged, they will obviously attract each other. And this is how the square materials will actually stick together. So just write down the answer over here. During rotation, because of friction, between the pieces of materials, electrons are transferred. Electrons are transferred, and one square become making one square negatively charged, making one negatively charged. Then finally I'll write that the squares have become oppositely charged, so opposite charges attract each others, or opposite charges will attract. The squares have become oppositely charged, so they attract. Okay, and that is your final answer for part B. I hope that was clear. Let's move on to the next one. The table shows some of the students' result for wool 5.4 Newton, polyester 3.2, and for acrylic 6.5. Explain which type of graph is the most appropriate to present these types of result in this investigation. Obviously, this is what? A discrete value data, right? This is not a continuous value. This is a discrete data type. So for this type of graphs or this type of data, only a bar chart graph will be suitable, not a continuous line graph. So I'll just write bar chart because the data is discrete. For those of you who do not know what discrete is basically about, 1 minute, I think I made a mistake about the spelling. This is discrete. Okay, discrete is basically, these are not continuous value, right? For the force required to pull apart the woolen squares were exactly 5.4. They were not like, continuous value. That was exactly 5.4 for wool, again exactly 3.2 for polyester, again exactly 6.5 for acrylic, right? These are exact values. These are not given over ranges. If they were given over ranges, then I would have chosen the continuous line graph, but these are given with exact values. So these are specific discrete values, which are known as discrete data. And whenever your data is discrete, you always draw a bar chart. This is how the bar chart would look like. 5.4 height for your wool, and then again 3.2 height for your polyester, and then finally 6.5 height for your acrylic. Okay, this is for acrylic. This is how bar charts will be represented. Okay, then after this they want to link a formula for charge, current, time. This is obviously the equation Q equals to IT. So charge is symbolized as Q, current as I, and time is obviously symbolized using small t. Right, that is your final equation. After this, now it says that when the squares of material are pulled apart, there is a small spark, and there is a current of this much ampere in the air for the time of this much second, and we need to calculate the charge that is transferred in between these seconds, which is obviously going to be what? 4.3 multiplied with 10 power negative 6, obviously multiplied with 2.3 multiplied with 10 power negative 3. Sorry, this is 4. Okay, correct. 4.3 10 power negative 6 multiplied with 2.3 10 power negative 3, and this will give you your final answer as 9.89 into 10 to the power of negative 8 coulomb. Okay, that is your final answer. Let's move on to the next question. This is about circuits. We need to state a formula linking voltage, current, and resistance, which is obviously voltage, current times resistance. Okay, now in this circuit specifically, we can understand that this entire combination of this 17 and 6.2 ohms are connected in parallel, right? So for parallel circuits, let me just write this down over here. For parallel circuits, current is same and voltage is different. So I'll just write this down, that current same and no, actually I was doing wrong. Current gets divided and voltage is going to remain same for parallel circuits. Now over here they want to calculate the voltage across that 17 ohm resistor. Specifically over here I can easily calculate the current voltage in that branch. That is going to be current multiplied with resistance, and again current has to be converted from milliamps to amp. That is basically 83 into 10 to the power of negative 3. 10 to the power of negative 3. So voltage is 83 10 power negative 3 multiplied with 17, which is 83 10 power negative 3 with 17, and that gives you 1.411 volt, so which is 1.411 volt. And then again state the voltage across the 6.2 ohms resistor. Since I already know that across a parallel circuit the voltage remain constant, so if the first one was receiving 1.411 volt, then the next one, or the lower one with the 6.2 ohm resistor, will also receive the same 1.411 volt. So this is going to be 1.411 volt, and that is your final answer. So we'll move on to the next question then. Calculate the current in the battery over here. So as I've already stated, that voltage at any part in the parallel circuit is same. So the voltage over here is 1.411. Over here also it is 1.411, and over here also it is 1.411. So the total voltage of the battery is also 1.411, and since this is a parallel circuit, the current or the total resistance over here is actually I do not need to calculate that, as current is divided and I already know what is the current passing through the first and second branches. Addition of these two currents will eventually give me the total current of this circuit across the battery also. So that is basically 83 plus 228 milliamps. So over here, as they were asking you to calculate the current in the battery, current total is going to be 83 plus 228 multiplied with 10 to the power of negative 3. So 83 plus 228 multiplied with 10 to the power of negative 3, and that will be 0.311 amps. Okay, that is your final current. And finally, again in diagram 2 shows a second circuit built by the student using the same battery and resistors, but this time this is in series connection, right? And then again in series connection your current is going to be divided. So current remains same and voltage will get divided. Okay, so current is same and voltage is divided. And explain how the current in the battery will change now if the resistors are connected in series. You do not need to do any calculations over here in your answer, but I know as these are connected in series, current will be divided. Sorry, wait 1 minute. How the current in the battery will change now the resistors are connected in series. Yeah, I'll just write that for both the resistors, the overall current will increase, right? Because previously the 17 ohms resistor in the parallel circuit was receiving 83 milliamps of current, and now it will receive the total almost this what 311 milliamps of current. And this 6.2 ohms was also receiving 228 milliamps of current in the parallel circuit, and now for the series circuit also it will receive that 311 milliamps of current. So that means overall in series circuit the current is same for all the circuits, which means that for both the resistors now their current across each resistor will increase, right? That is your final answer. So I'll just write down the answer over here, that current across each resistor will increase to 311 milliamps as in series circuit all the resistors receive same current. Okay, that is your final answer. Okay, then this is it for your question, and we'll move on to the next question then. This is from June 23 to PR. The diagram shows the inside of an oscilloscope, and electrons leave the electron supply and accelerate towards the screen. Okay, this is your electron supply. They will leave the electron supply and they will accelerate towards the screen. The stream of electron hits the screen and the grid is connected to a positive terminal of a high voltage power supply. Explain in terms of movement of particles how the grid has become positively charged. Because how the grid has become positively charged, because it was also losing electrons, right? By losing electrons it becomes like there will be eventually a surplus of positively charge in there, which will eventually cause the total grid to become positively charged. So I'll just write down the answer. To have a surplus of proton, causing it to be positively charged. Okay, now after this we need to link kinetic energy, mass and velocity over here, which we can understand. So it is going to be what? Kinetic energy half mv square, right? And then again we need to calculate the speed of an electron when it has a kinetic energy of this much and the mass of an electron is this much. I can easily calculate the speed, which is going to be kinetic energy 1.3 10 to the power of minus 15 multiplied with 2 divided by the mass was 9.1 into 10 to the power of minus 31 and everything under a root, right? If you just calculate the velocity, it will turn out to be 5.3 into 10 to the power of 7 meters per second. That is your kinetic energy, or that is your speed of the electrons in that stream of electrons. And then again, it says the stream of electrons spread out as it travels towards the screen. Explain why why the electrons in the stream move apart from each other. Because in the stream, everyone is electrons, right? The stream is made up of electrons, and all of them are negatively charged, and like charges repel. So that's why, because of repulsion, they will move away from each other, and that's why the entire stream spreads away. So we'll just write down the answer that in the stream all the electrons are negatively charged and like charges repel. In the stream, all the electrons are negatively charged and like charges repel. Okay, this is the answer for part B. Then in part C, now it says that the oscilloscope can cause the electrons to move in a circle. This produces a circular pattern on the screen, and where each box over here represents 1 centimeter. So calculate using a scale, so use that scale to determine the radius over here. I can consider this as the center. This is basically 1, 2 and 1.5, right, or 0.5, right? So this is going to be 2.5 centimeters as your radius. This is 1, 1 and 0.5, so 2.5 centimeters. After this, again we need to the time taken for the electrons to complete one orbit of the circle is 24 milliseconds, which is basically 24 into 10 to the power of minus 3 seconds. And we need to calculate the orbital speed, which is now 2 pi. Radius is going to be 2.5 divided by 100. So 2.5 into 10 to the power of minus 2 divided by 24 into 10 to the power of minus 3. And if you calculate all of these things together, you'll get the orbital speed as 6.5 meters per second. That is just 6.5 meters per second. Okay, let's move to the next question. November 23 2p. A cleaning sponge product is applied to a car. So it's applied to a car using a sponge pad. The sponge pad is rubbed against the car to apply the cleaning product. Some parts of the car made of metal and other parts are made up of plastic. The metal parts of the car are earthed. Explain why the pad becomes charged when rubbing the plastic parts but not when rubbing the metal parts. That's because the metal is being earthed, right? That means if the metals are earthed, which means there will obviously be a transfer of charges, transfer of electrons from the pad to the metal, but the metal will not hold that. In metal, as they are entirely earthed, the metal will the electrons will actually have a very lower resistance pathway to the earth wire, so eventually there will be no buildup of negative charges in the metal sections. But for the plastic part, which are not connected to the earth wire, that means obviously now when the electrons are getting transferred from the pad to the plastic surface of the car, they will not have any escape out of that. So if the electrons from the plastic does not have any escape, they obviously cannot move out of that. They will eventually be trapped onto the plastic surface, eventually increasing the overall eventually causing the plastic parts to become charged, right? That is the case over here that is occurring. So this is your also answer for this part. So let's just write the answer that during rubbing because of friction, there will be transfer of electrons. During rubbing, because of friction, there will be transfer of electrons, and these electrons will get transferred. Wait 1 minute. During rubbing, because of friction, there will be transfer of electrons. Transfer of electrons. Okay, then just let's move on to the writing part for metal and plastic. In metal, they are earthed. So electrons can easily escape through the electrons can easily escape through the non wait 1 minute. So electrons can easily escape through the low resistance path, but in plastic electrons get trapped, right? Oh wait, sorry, actually they were talking about the pad becomes charged, not the plastic parts. That is again because of the same cause that wait 1 minute. No, actually this is going to be the other way around then. No, actually this is the final answer, but I think in the mark scheme they were adding one point that plastic is an insulator whereas metal is a conductor. Okay, for this reason this entire buildup of charges are occurring. So lastly I just add that point that also plastic is an insulator whereas your metal is a conductor. Okay, now after this it says that sponge pad is held near a metal post that is connected to the ground. The sponge pad discharges with a small spark through the air to the metal post, and the sponge pad stores this much millijoules of energy in its electrostatic store. The voltage between the sponge pad and the metal pad is this much volt. Calculate the charge transferred by the spark. We can obviously calculate that using the equation energy is equals to voltage into charge. Okay, we want to find out the charge over here, so equation is E is equals to VQ, where Q will be E over V, right? Energy over voltage. That is energy is 5 into 10 to the power of -3 divided by 6,000, and eventually the charge over here turns out to be 8.3 into 10 to the power of -7. So 8.3 10 to the power of -7 coulomb. That is your charge over here. Let's move on to the next question. The small spark between the sponge pad and the metal post demonstrates that the sponge pad is charged. Describe a different experiment that would demonstrate that the sponge pad is charged. And you may draw a diagram over here. We can, since I already know the sponge pad is charged, right? So I will just have to bring another uncharged rod near the pad, and if there is an attraction, then obviously this will indicate that the sponge pad was charged, right? So I can just draw a diagram over here. I know the sponge pad was maybe negatively charged, right? Or maybe it will be positively charged, and since it is positively charged, I will bring I'll bring a rod that is neutral. That means it will have enough positive, like equal positive and negative charges. That is what neutral indicates. And if they get attracted to each other, then obviously this would demonstrate that there is charge on the sponge, right? Or the sponge pad is charged. So your final answer would be that bring an uncharged to the sponge, and if they are attracted to each other, then the sponge pad was charged. Okay, So yeah, with this actually our electricity also ends. I am not actually able to complete the other sections for this revision paper, but I hope that watching the parts for electricity and kinematics was a little bit helpful, and I hope you guys will be able to like take notes from this part and solve your paper tomorrow as properly as possible. And then again for the last part, since this is going to be the end of your May-June session, and there will be no more revision papers or revision videos before the November session or October session again. So I'm just going to lastly remind you guys that if you guys are interested for our October 2024 crash courses for physics, Maths B, Pure Maths, ICT, and Biology. These are the subjects available for IGCSE. Please don't hesitate to knock me in WhatsApp or in email. You can also contact me through our Discord group. I will try to reach you guys as fast as I can. And then again, our new batches for May 2025 will start from the 20th of June of this month. We are providing a trial class for these subjects, maths, physics, and IT. So if you guys are interested, please inbox me in my WhatsApp and in my email. If you think that watching our revision videos were helpful before your exam, then you should consider joining our classes also, because our classes are 10 times more helpful. We provide 10 times more worksheets and recorded classes for our regular students, for our registered students. So if you think if you are interested for our classes, you can obviously join our free trial classes on 20th of June. Please attend that, and in order to join that trial class, please inbox us in our WhatsApp or email. Thank you for joining thank you for watching this video. Okay then, bye bye. Thank you for watching the video, and all the best for your exams tomorrow.